Today we are going to discuss two topics. One is areas in integration, that areas chapters, and other one is differential equations. Okay, so first let us see areas. So areas, the one point which I want to say very important, that is for integration. Normally where the confusion will come is, okay, so first let me draw. Yeah, so for example, let's say you have one like this and other one like this. Okay, so I want to find area bounded by y equals to f of x and y equals to g of x, these two functions, let's say. Okay, now so there is something called height function. Okay, I also call it as height function, or it can okay, so height function means the height of these rectangles. So if you take rectangle height to be like this, and if you keep adding all these rectangles, then you will get the required area. So how will you define the height of this rectangle? See, width of the rectangle, because since we are taking in x direction the width will be dx. Okay, so each rectangle will have some width, no? The width of that will be dx, because in x direction the width is there. Okay, so when it comes to height, you all know that in 2D, if I take 2 points, which are like, if you join them, if it is a vertical line, then the length of this will be nothing but, first thing, these 2 points will have same x coordinate because they are on the same vertical line. So y coordinates will be different, y1 and y2. So then the length AB will be upper point y coordinate minus lower point y coordinate. Okay, same thing here. One second. If you see this graph, I'm marking 2 points now, A and B. Okay, so both of them will have the same x coordinate since it is a vertical strip. Okay, I call it as vertical strip. Okay, now what will be the y coordinate of point A? It is on y equals to g of x. Y coordinate will be g of x. What is the y coordinate of point B? F of x. So what will be the height function here? F of x minus g of x. This will be the height of the rectangle. And what is the width of the rectangle? Dx. And if you add them, this integration symbol is nothing but adding them. So integrate from this variable of integration is x. So starting from A to B, if the point of intersections are A and B, A to B, this will be the area. Okay. Same thing what we do. So what you have to do when you have to, when you're taking vertical strips, draw the figure like this. Then mark these 2 points A and B. Both of them will have same x coordinate. Just write the y coordinate in terms of x. Then write height dx, that should give the area from whatever x coordinate to whatever x coordinate. Same way, if you have this kind of figure, let's say, okay, this, and there is a line which goes like this. Now I want the area bounded by this line and this parabola. Okay, now here if I take vertical strips, then it will look like this. Now you see the below point I am saying A, above point I am saying B. Both of them x and x will be there. Okay, now what is the height of this rectangle if I ask you? Okay, so if this line function is f of x and the parabola is, let's say, g of x, you can't say it is g of x minus f of x now, because there are some rectangles here whose above and below both are like, below one is not line, no? So there is a discontinuity. Okay, but see here, if I take horizontal strips, for example here, if I start taking horizontal strips, your left side of the horizontal strip is always on parabola, right side is always on the line. So your left point and right point, the nature is not changing throughout this one. So that's why you take horizontal strip. You will not take vertical strips. Okay, the main decision will be on whether I have to take a horizontal strip or vertical strip. No? That will be the main dilemma normally in areas questions. Other than that, areas is a very easy chapter. Okay, so vertical strips when you have to take. Here, for example, in the first question, I have taken vertical strips. Now, if I take horizontal strips also, no problem. Why? You can see here, if I start taking horizontal strips, your left side and right side curve is not changing. Left side is always f of x, right side is always g of x. So the width of the rectangle can be easily written. Always, it is not changing. Okay, that function. Okay, so how do you write the width of the rectangle? Means, let us take this particular rectangle here. Now these two will have same y coordinate. So write y like this, y, y. Now here x in terms of y we need to write. Okay. So whenever you had take horizontal strips, your x coordinate you have to write in terms of y. Let's say that is f1 of y, x in terms of y. This also you write x in terms of y, g1 of y, let's say some g1 function is there. Okay. Then what is the width? So in a 2D, whenever you have a horizontal line like this line segment, both will have same y coordinate. So x1y and point B will be x2y. What will be this length? X2 minus x1. Right side x coordinate minus left side x coordinate. So here also, what will be the length of this strip AB? Right side x coordinate f1y minus left side x coordinate g1y. And what is the height of this rectangle or width of this rectangle? That will be dy, because in y direction, not dy. Then you integrate. Now the limits of the integration will be y. So what is the y coordinate of the starting point to what is the y coordinate of the ending point? If the starting point y coordinate is A, ending point y coordinate is B, then A to B, like that. Okay. Chalo, let us see some examples. Then I hope it will be more clear. So let us take this one. Area bounded by these two. First, let us draw those two figures. Okay. X and y axis. First, x equals to minus 2y square. X equals to minus 2y square will be something like this. Okay. Now, other one is x equals to 1 minus 3y square. The graph will be something like this. When x is 1, y will be 0. But you need to be careful. It will be like this. Okay. Now, there will be two intersection points here. Okay, for these two graphs. Let's call it A and B. Now, again, graphing is very important part in areas. You should be able to draw the graph precisely. Now, how I am saying two intersection points are there means, actually the first point is, already I know this question. Otherwise, like you just solve them if you're solving this one. Okay, 1 minus 3y square, y square equals to 1. That means when you solve these two curves, you will get the points of intersection. No? So these two curves will meet when y is 1 and minus 1. So if you put y as 1, x will be what here? This graph, minus 2 you will get. Minus 1 if you put, minus 2 only you will get. Here, y if you put plus or minus 1, x you will get minus 2. So that means when x is minus 2, the intersection points are these two. Y coordinate will be 1 and minus 1. Okay. Now I want the area bounded by these two. So I need this area. This one, 1 second, let me just shade it. This part, correct? Now, how do I get that area? By taking vertical strips or horizontal strips? That is what you need to think. Horizontal strips, right? Because if you take horizontal strips, what is the advantage means? Always the left curve and right curve, they are not changing, you see, throughout this area. Okay. Now, what you do, take one strip, let's call it AB is already taken. So PQ, let's say. Okay. So for this strip, both y coordinates will be same. So first you write y, y. Now x coordinates you write in terms of y. So what is the curve? First curve, x is minus 2y square. X coordinate will be minus 2 times y square. That's it. Second curve is 1 minus 3y square. Now what is the width of this rectangle? 1 minus 3y square, right side x coordinate minus left side x coordinate minus 2y square. Correct? This is the width. And what is the height of this rectangle? Dy. Now you need to add all these rectangle areas. From where to where? Y coordinate is changing from -1 to 1. Na? So -1 to 1. So if you integrate -1 to 1, now this will be 1 minus y square dy. You will get your answer. Okay, simple integration only. No? Next, we'll come to these kind of questions slowly. Yeah. Next one, area bounded by y equals to x square plus 1 and the tangents drawn through it from origin. Okay, so how will you draw y equals to x square plus 1? It will be like this. This is y equals to x square plus 1 graph. And the tangents. So that means from origin, if you draw tangents, they will look something like this. Sorry, my diagram is not so perfect. Okay. Now this area we need. Okay, area bounded by this one. Okay. Now in this case, already we know the equation of the blue color curve. That violet color line, whichever is there, that equation we should know. Then only we can find the area. But before that, we can just analyze, should we take the horizontal strips or vertical strips? If I start taking horizontal strips, na, the problem will be, you see, if I take horizontal strips, then left side curve is blue, right side is violet, correct? But only up to some point. Na? After that, what happens? If you talk about this region, your left side curve is changing, right? It is violet. Right side is also violet. Okay. But since these two are different line equations, that means different functions will be there for them. So with horizontal, there is a change which is happening in the left and right. Na? So, but if you take vertical, like this, always the above one is blue, below one is violet. So you will decide that we have to take vertical strips. And that too, I just need to find the area from 0 to right hand side, from whatever this point is A, let's say. Because the other area will be exactly identical to it. Na? So 2 times it will be. 2 times that integration will be the required area. So let us see how to find this, whatever red color strips I have drawn, na, that area. For that, what you need to know, you will take a strip. Sorry. So you will take a strip, one particular strip. Let us use a different color, one particular strip. What you will do, you will write the above point and below point. Both will have same x coordinate. You will write x comma y coordinate. What is the y coordinate of the blue color curve? X square plus 1. So you will write x square plus 1. Now below curve is a line. Na? We don't know what is that line equation. If you know the line equation, then only you can write y in terms of x. Okay, let us find the line equation. How do we find the line equation? From origin, we need tangents. Na? So this, whenever you need tangents from external point, assume the point on the curve to be parametric, like this. If x coordinate on this curve is t, y coordinate will be t square plus 1. What is the slope of tangent at A? Slope of tangent at A will be derivative. First, slope means dy by dx you will do. You will get it as 2x. So at x comma, sorry, not at x comma, at t comma t square plus 1, that point, what will be the slope of the tangent? It will be 2t. Now this slope of the tangent must be same as slope of OA, na? Because it is passing through origin. What will be slope of OA? y2 minus y1 by x2 minus x1, t square plus 1 by t. Now equate both of them. These two must be same. So 2t equals to t square plus 1 by t. So which implies t square equals to 1. T you will get it as plus or minus 1. So that means these touching points will be 1 comma 2, and on the left side it will be minus 1 comma 2. T can be plus or minus 1 we are getting. No? So once you get the touching point, then the slope is nothing but 2t. No? That is 2 times 1, 2. So this line equation will be y equals to 2x. So this point, what will it be? X comma 2x. Y coordinate will be 2x. No? Normally, both the equations will be given, but here it is given indirectly. Okay, that's why all this work we are doing. But normally, if you know both these upper and lower curves, then what will be the height function? Upper y coordinate minus lower y coordinate. That is x square plus 1 minus 2x. What is the width? Dx. In x direction, the width is there. No? And your integration will be from where to where? If you do integration from 0 to 1, x coordinate 1, 0 to 1, you will get that area, whichever is there here, yellow. I'm shading it with orange. Okay. If you do 2 times it, I will get the required area, because left side area will be same as that one. So that's all. That will be the answer. Okay. Next. One second. Let me take, yeah. This is another interesting question. You see, area bounded by the parabola. This is one parabola. This is one parabola. In the beginning, we have seen something like this. Okay. But they have given one more straight line also, they told. Okay. And the straight line y equals to 2. Okay. Simple. What you do is, first let us solve these two. How do we solve these two? X square is y by 4. X square is 9y. To solve, let us equate y by 4, 9y. Y square is equals to 1 by 36, which implies y is equals to plus or minus 6. So if you put y is equals to 6, then x square is equals to 36. Sorry, not plus or minus 6, plus or minus 1 by 6. Okay. So if you put y as 1 by 6, then x square equals to 9 by 6, which is 3 by 2. X will be plus or minus root 3 by 2. Okay. So now if I start drawing, you can't substitute minus 1 by 6, because if you put y as minus 1 by 6, you will get x square as minus 3 by 2. Not possible. No? Okay. Now, x square equals to, so these two if I draw, one is y is equals to 4x square. Is y is equals to 4x square. Other one is y is equals to x square by 9. Okay. Now, these two graphs, what are we getting information? They are intersecting or not intersecting? When x is root over 3 by 2, both the y coordinates are same. That is what we are getting. No? And what are the y coordinates of both? 1 by 6 for both the graphs. So, which means when x is root 3 by 2, root over 3 by 2, or minus root over 3 by 2, the y coordinates of both the graphs are same. That means they are going to intersect here. So which means the second graph, I will draw something like this. Okay. Not bothered about the exact, okay, figure and all these things. Next. And the straight line, what the, one second guys, root over 3 by 2 if I take, one second. No, there is some mistake which I have done. Sorry. I'm very sorry, guys. Sorry. Normally, this kind of mistakes should not happen. Yeah, they don't intersect actually. That's what I was wondering. Because here I made a mistake. When I equate these two, what happens? How will I get y square? I'm very sorry. Already you would have texted in the chat box, but I couldn't see with the screen share on. Okay. Sorry, guys. So if I equate these two, I'll simply get y equal to 0. Na? Only one point of intersection, that is at origin. That's all. So the second graph will be something like this. Okay. So this is nothing but y is equals to x square by 9. And y equals to 2, they are saying. So draw y equals to 2. So it will be somewhere here like this. Sorry, on the right side, the symmetry I have not maintained. Yeah. So then y equals to 2 will be like this. Now, area bounded by these three means you have to see the area for which these three are the boundaries. So can I say this one? Now, the only question which I will ask you now is to find the area which I am representing right now with red color pen. Okay. Will you take horizontal strips or vertical strips? That is the only question. Okay. Think for 30 seconds. Obviously, one thing you would have observed now, only half one side area, if you find, that is enough. because the other area is going to be identical, left side one. Okay, so at least for finding this half of the area, will you use horizontal strips or vertical strips? Please answer. Horizontal. Very good. Horizontal strips is right. Okay, because when you take horizontal strips, always the left and right side curves are not changing. No? Okay, and these horizontal strips will go from y equal to 0 till y equals to 2. So your integration limits are clear for you, 0 to 2. Now once I take horizontal strip, each of them, how I should write is both will have same y coordinate. Okay, so x coordinate I need to write. For the blue curve, how to write the x coordinate in terms of y? Your x will be root over y by 4, which is root y by 2. You may say, sir, minus root y by 2 also will come, na? Yeah, but that will be on the other side, this one, because here two sides it is there, na? Because when you write root y by 2, where I have written, yeah, x coordinates are positive. On the right side, it will be root y by 2. On the left side, half of the parabola will be minus root y by 2. Okay. So this half is root y by 2. The other half, this half will be minus root y by 2. Okay. Fine. Root y by 2 I'm writing. What about the green color one? If y coordinate is y, what will be the x coordinate? 3 root y you will get. Now simply, what will be the width? 3 root y minus root y by 2. Now what is the height of this one? dy. That's all. If you integrate this, you will get the answer. Okay. Next. See this question. This is previous AEEE question. Very nice question. This is the area of the region bounded by the parabola. They have given some parabola and the tangent to this parabola at 2, 3. Okay. So this parabola drawing, this parabola is pretty easy, right? Why? Because already it is in standard form. Y square equals to 4ax type. But the vertex you will get by the reference. Now, what is the vertex now? 1, 2 is the vertex. 1, 2. Opening right side. So this is how the parabola will look like. Now they are saying what here? At 2, 3, you are drawing a tangent. So 2, 3 will be somewhere here. Now the tangent will look something like this. Okay. Now area bounded by, you see the boundaries of whatever area we need. By this parabola, a tangent drawn at 2, 3 and x-axis. So tangent, this parabola and x-axis together, it will be like this. Now we need the area of this part. Now tell me guys, will you take horizontal strips here or vertical strips to find this area? Any answers? Okay, I'll show the figure again. You have to find this area. You know the parabola equation. You can find the green color line equation, that is this line equation also. That is the tangent at 2, 3. Just by basic derivative you can find. Na? If you find the derivative at 2, 3, you will know what is the slope of the tangent. So if you know point and slope of the tangent, you can write that green color line equation. Okay. So let us just write by that time. You tell me whether horizontal strips I should take or vertical strips. If I differentiate, I'll get 2 times y minus 2 into dy by dx is equals to 1. So your dy by dx will be equals to 1 by 2 times y minus 2. So at the point 2, 3, if I substitute, I'll get 1 by 2. So equation will be slope is 1 by 2. So it will be x minus 2y is equals to 2 minus 6 minus 4. So this is the equation of the line. Okay. Parabola equation already we know. Y minus 2 whole square is equals to x minus 1. Okay. Tell me guys, whether you will use horizontal strips or vertical strips. Horizontal. Very good. Excellent here. Okay. Definitely horizontal guys. Because you know. Okay. That's why you have answered horizontal. Because when you take horizontal, always the right side point will be on parabola, left side will be on the line. There is no change anywhere, no disturbance. Every time it is like that. So what you have to do when you take horizontal strips, first you write y and y. Then x coordinate you write down. What is the x coordinate in terms of y for the line? X in terms of y will be 2y minus 4. So this will be 2y minus 4. Then for parabola, what will be x in terms of y? Y minus 2 whole square plus 1. So here you write down y minus 2 whole square plus 1. So what will be this width? It will be y minus 2 whole square plus 1 minus of left side x coordinate 2y minus 4. Now what is the width of the rectangle? Dy. Integration from where to where? From 0 to, in this area, in this rectangles, y coordinate is changing from 0 to 3. Na? Okay, 0 to 3. Simple integration, you'll get the area. Okay. Next. So there are some more questions on this. Okay. So fine. So one last question. Then afterwards we'll go to differential equations. Okay. See, these are this is a pretty famous model only. That is, this is little different to whatever we have done. So what they are saying is they have given a function f of x. Okay. They are saying it's a bijective function. Okay. So if it is a bijective function, it is both 1, 1 and on 2. It will have inverse. But writing inverse for this function is like we can't do it. Okay. That means writing x in terms of y is almost impossible for this one. Fifth degree, you need to write for a second degree equation, you can write x in terms of y. But for fifth degree, writing x in terms of y, like very difficult. Okay. You can't write as a function. Okay. But what they are asking, area bounded by g of x. What is g of x? Inverse of f of x. Okay. So if f of x graph is like this, then g of x graph will be like that. Na? Inverse of image with respect to y equals to x. So they are asking area bounded by g of x, x-axis, and the ordinate at 12. That means this x equals to 12. Okay. Now you can see clearly that if x is 0, y is 0 for this graph. So 0 will map to 0. That is f of 0 is 0. So f inverse 0 will also be 0. Since g is inverse, that means if you input 0 to inverse function, you will get 0 only. Na? Okay. So that means the inverse function will pass through origin. So like this, the inverse graph will be. From 0 to 12, we need the area. Okay. So can I write like this? Integral 0 to 12, f inverse of x dx we need to find. This is what we need to find. Na? Okay. And what we know what is f of x. That's all. Now, how to find this integral, guys? We know what is f of x, but we need to find 0 to 12 f inverse x integration. Okay. Anyone? What we have to do? Physics question you have seen. No? No. Yeah. So coming to this one. So whenever you have inverse function integration, but f of x is given, not f inverse x. If they have given f inverse x, we could have done it easily. Okay. So what you do is simple. Take f of x as t, substitution, or one second, not f of x, f inverse x, you take it as t. This substitution you make. Okay. You will see how easy it will be. If f inverse x is t, can I say x is f of t? That means dx will be f dash of t dt. Okay. Done. Now, this integration, f inverse x is what here? T. Dx will be what? F dash of t dt. Now, limits. Limits are for x. Now, you need to find limits for t. So, what is the lower limit for x? 0. So, lower limit for t will be f inverse 0. F inverse 0 is 0 only. No? Already we have seen. Because 0 will map to 0. And then upper limit. Upper limit of t will be f inverse of 12. F inverse of 12 means for what value of x, f of x will map to 12, correct? So which element is mapping to 12? That is only f inverse of 12. So if you put x equals to 1, it will be 12 only, no? 6 plus 4 plus 2. So f of 1 is 12, That means f inverse of 12 is 1. So upper limit will be 1. Change in variable. So 0 to 1. That's all. Now how to find this integral? Again, you know what is f dash of t, no? What is f of x? You know already. What will be f of t? It will be 6t power 5 plus 4t cube plus 2t. So what will be f dash of t? It will be 30t power 4 plus 12t square plus 2. Now f dash of t we know that you substitute here. So integral 0 to 1 t times, what is f dash of t we have got? 30t power 4 plus 12t square plus 2 times dt. Done. No? That's all. Okay. This integration you can do no? Easily. T power n integrations only. Fine. Yeah. Next, differential equations we will see. Now, initially there will be some questions on differential equations. Find the order and degree of some differential equation, and then writing differential equation if some family of curves are given like this. Okay. Yeah. But today I will not be discussing those because yeah, they are part of the syllabus. But again, in the given time, whichever is of more important weightage in that chapter, I will be discussing them only, no? Mostly. So if you want, you can just take screenshots for practice, or you have reference books. Na? They are easy to understand. You can do it. Okay. Degree of a differential equation and formation of differential equation. They are easy concepts only. Okay. So I'll come to little complex parts. Okay. So again, in that also, in differential equations, you have various techniques to solve them, variable separables. This is the basic part. All x terms one side, all y terms one side. This has to do mainly with whether you can integrate something or not. Okay. So like for example, here, all x terms one side I can bring na? X into 1 plus x square. You bring this 1 plus x square left side. This also you bring left side. And remaining all the y terms you bring one side. Y square, dy, y, all this one side. And all the black colored ones one side. Okay. So what you will have if I do that? So dy, y dy by 1 plus y square. All x terms one side dx into 1 plus x square by x into 1 plus x square. Now just you need to integrate both sides. Okay. You will get the solution. So that is only the variable separables. Pretty straightforward. You need to know how to integrate. Okay. For example, here this question if I see. So as soon as you look at it, it doesn't look like variable separables, but you need to use sin c plus sin d formula. What is sin c plus sin d? It is 2 sin c plus d by 2 into cos c minus d by 2. So tan y into dy by dx, sin c plus sin d, 2 sin c plus d by 2, which is x only, cos c minus d by 2, cos y you will get. Now you can separate all the x terms and all the y terms. No? Dx, 2 sin x, one side, and remaining all the y terms, one side you can bring. Then you can integrate. Okay. Next, there is something like this, for example. This is called, one second, let me show the question. Sorry, I'm not showing the question. Yeah. So dy by dx is equals to x plus y plus 1 whole square. Looks very simple, but actually not that simple. Okay. It is not variable separables because you can't separate the x and y terms, because when you square it, you'll have all of them mixed together. You can't separate out x terms into y terms. Correct? So then what to do now here? Anyone? Very good. What substitution? Correct. I think typing will take some time. Na? That's why some delay. The what Nishant has told is correct. Basically, what you do is substitution. Okay. So that is x plus y plus 1. Or actually, instead of substitution, I will say, okay, fine. Substitution is the correct word. X plus y plus 1. Let's take it as some variable t. Okay. Now, the important part is whenever you are doing substitution, you are replacing this by t square, it will happen. Okay. Then, so now a new variable introduced. So it is like there is space for only two variables to solve. Okay. Whenever you see a differential equation, in the whole differential equation, you will see only two variables, na? X, Y. Generally, that is what you do. Okay. Now, if I'm introducing a third variable t, these two variables which were inside, now t is introduced. So one of these two variables must not be there now in the new equation. Now you decide whether x must not be there or y must not be there. Okay. Usually we take in such a way that this one dy by dx denominator whatever is there na variable, that variable we eliminate. Like if 1 plus dy by dx, if I differentiate on both sides, I'll get dt by dx. No? Sorry, that a variable we keep it. The other one we eliminate. So what is dy by dx? It is dt by dx minus 1. So that you write it here, dt by dx minus 1. Now the y variable is not there. No? Okay. dt by dx is 1 plus t square. Now this is the variable separable only. dt by 1 plus t square is t square. Dx, you know how to do after this. Okay. Next. So whenever you have like this square inside both variables, you take that as t. Okay. That is only variable separables. You will get it, but with some substitution. Now, whenever you have something like this form, now there are three cases. Okay. Whenever you have something like that. Okay. So for each case, I have taken one example. Okay. So first case is a2 plus b1. If it is 0, you will follow one method. If a1 by a2 is equals to b1 by b2, yeah, obviously not equals to c1 by c2 because all three are equal, then cancellation will happen. No? Now, that means, what does it mean a1 by a2 equals to b1 by b2? These two lines are parallel. If these two lines are parallel, you will follow one method. Third case, if a1 by a2 is not equals to b1 by b2, you will follow another method. Okay. So let us see one by one. If this kind of scenario happens, easiest one, this is level 1 difficulty, this is level 2 difficulty, this is level 3, I would say. So level 1 difficulty is very easy. Whenever you see that this denominator x coefficient, numerator y coefficient, if the sum is 0, then just cross multiply. That's all. You cross multiply, you'll get the solution. Let me take one example. Let's say here, denominator x coefficient, numerator y coefficient. They are both adding to 0. Cross multiply. You will get 2x dy plus 2y dy plus 3 times dy is equals to this dx. If I multiply this side, x dx minus 2y dx plus dx. Now, whenever you do this, there are some easy terms which you can integrate directly. This you can integrate, this you can integrate, this you can integrate, because the variable of integration and the function is of same. This you can integrate. The problem is what here? These two. This one and this one. Now what you do, combine those two red terms and you will see what will happen. If I combine those two, if I bring that left side, I'll get 2 times x dy plus y dx. And remaining terms as it is equal to 0. Now what is this x dy plus y dx? That is d of xy only. Plus remaining ones also. Now I'll write 2y dy plus 3 dy. Bring the remaining one x dx minus dx equal to 0. Now what you do? You just integrate everywhere. Integral, 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 integral. What is integral of derivative of xy? Xy only. No? This will be y square. 2y integration is y square. 3 times dy integration is y. X dx integration is x square by 2 minus x. Integration constant 0. This will be the answer. Okay. Now, if the two lines which are involved are parallel, then also the procedure is easy. Second level difficulty I was saying. No? So here dy by dx is what here. So whenever you have like this two lines parallel, simple. Take the substitution. X plus y, you take it as t. Then what is 1 plus dy by dx? it will be dt by dx. So this dx, if it goes, it will be dy by dx like this. So let us write x plus y is what here? T. And what is this one? 3t minus 4. Sorry. 3t minus 4. And what is dy by dx? dt by dx minus 1. Now just rearrange the terms. You will get dt by dx minus 1 is equals to minus t by 3t minus 4. If you send that one right side, dt by dx will be equals to 2t minus 4 by 3t minus 4. Now this is variable separables only. Na? All t terms one side you can bring and then integrate. Okay, that is your second. Third one, whenever you have like this, what you need to do? First, simple substitution. That is your x, you will write it as capital X plus alpha, and y you will write it as capital Y plus beta. That substitution you will make. And what is alpha and beta? This is nothing but point of intersection of both these lines. So if I see these two lines, since they are not parallel, they will intersect. Now, what is that intersection point? 1, 1, you will get it. Okay. So now you take small x as capital X plus 1, small y as capital Y plus 1. If I do that, your d small x will be d capital X only. D small y is d capital Y only. Substitute d capital Y by d capital X will be equals to small x is what here? Capital X plus 1 plus 2 times small y is nothing but capital Y plus 1 minus 3. Same way denominator also 2 times capital X plus 1 plus capital Y plus 1 minus 3. So if I simplify, it is capital X plus 2 times capital Y by 2 times capital X plus capital Y. Now this we call it as homogeneous form, which we will see later on. Okay, next. So up to this point, you right now you all have knowledge, na? Now next, homogeneous something we'll see. Okay, we call this as homogeneous. Already you know what is homogeneous. Both are of same degree, na? Every term is of same degree in numerator and denominator. So it is homogeneous. Okay, and both are numerator and denominator the same degree of homogeneity. So you have some procedure. Now you'll take y is equals to vx. Then you can solve from there. Okay, so we'll see homogeneous differential equations. Okay, so homogeneous differential equations, you'll have something like this, and your right hand side function, instead of y, if you put vx, for example, or okay, I hope you should know it beforehand only, like homogeneous. I will just discuss the example, because if I start explaining everything, time will not be sufficient. Okay, so now let's take this example. Okay, now solution to this differential equation. So one example, so whenever you have homogeneous differential equation, this substitution you will make now, y equals to vx. Okay, now here just you observe what this differential equation, you will see that, sir, in homogeneous differential equations, normally the differential equation will look something like this. Yes or not? Because here if I write dy by dx, I will get minus of 3xy plus y square divided by x square plus xy. This is what you get if you write dy by dx. Now you see two terms are there in the numerator. What is the degree of those two terms? Second degree. Denominator also two terms are there. What is the degree? Second degree. All the terms are having the same degree. No? So it is homogeneous differential equation. Okay. So for homogeneous differential equation, the substitution is y equals to vx. So dy by dx will be UV rule if I apply. dv by dx, x dv by dx plus v times dx by dx is 1. Okay. So now dy by dx is what here? X into dv by dx plus v, and minus what is there here? 3 times x into what is y? Vx. And y square is v square x square divided by x square is x square only. X into y is vx. You will write like this. So finally you will get something like x into dv by dx plus v is equals to minus of 3v plus v square by 1 plus v. This is what you are getting. Okay. Now, if you send v right side, then it will become variable separables, because if I send v right side, this whole thing will be function of v. Correct. So that and this you can combine one side, and remaining whatever x terms are there, you can combine. That is the idea of homogeneous. No? Okay. But now if you look at this question, I can't talk about degree because sign is there. Na? Yes or not? Degree is normally for polynomials only. For sine y, what is the degree of sine y means? There is nothing like that. Okay. So somehow we need to get rid of that one. Okay. First, like you see, what we do is here dy by dx, I can write this one as sine y plus x is there. And what is sine 2y? 2 sine y into cos y minus x cos y. I think from denominator cos y will be common, and multiply it left side. What do you get is cos y dy by dx is equals to sine y plus x by 2 sine y minus x. This is what we are getting. Now, simple. Now, sine y, you take it as some variable. Let's say that variable is t. Then what will be cos y dy? It will be dt, just like in integration. So this will be dt. So dt by dx will be equals to t plus x by 2t minus x. Now this becomes homogeneous. Na? You see, all the terms are same degree na? In numerator and denominator. For homogeneous, what is the substitution? Normally we take y is equals to vx, but here y is not there, t is there. Na? So t equals to vx. Now you can do proceed after this. Okay. Now, for example, if I take this one, okay. So what is there? Your dy by dx is equals to minus of 1 plus 2 times e power x by y by 2 times e power x by y into 1 minus x by y. Correct? Yeah. Now, y equals to vx will not be a good idea here. Why? Because if you put y equals to vx, then here x by y will be 1 by v. Na? So which one do you like? E power v or e power 1 by v? Obviously e power v. Na? E power 1 by v is more complicated. So what we will do here is we'll make x equals to vy here. Okay. That will, so because now you can write dx by dy. Now you should not write dy by dx because x is there. X is you are writing in terms of y. Na? See, y is equals to x square is there. Y in terms of x you are writing. Then dy by dx you will find. Na? Now here x in terms of y you are writing. So find dx by dy. What is that? V plus y dv by dy. Correct? So now you need to replace dx by dy by this. So dy by dx is that. Dx by dy means just inverse it both sides. So dx by dy will be v plus y into dv by dy. Now everything will get reversed. No? X equals to vy means 2v into 1 minus, sorry, not 2v, 2 times e power v into 1 minus v, minus sign will be there, 1 plus 2 times e power v, like this. Okay. Now, if you send v one side, then you will have all v terms one side. Okay. Then it is variable separables only. Okay. So that's the idea, guys, for homogeneous differential equations. Now comes the most important part out of all, that is linear differential equation. Okay. So linear differential equation. Okay. So where does this linear term come from? That means linear differential equation of first order. You all know what is first order. So dy, order of the equation is 1, that is dy by dx, dy by dx, dy by dx, first order only. No? All are first orders. Okay. Now linear means, what we mean is, Now, there is something called dependent variable and independent variable, right? For example, dy by dx is there. For example, what is velocity? Dx by dt, correct? So you can't control time, but displacement is something which you can control. That is how we normally talk. Time is not in our control. Time will go on. But how you accelerate a vehicle or something, what you are controlling? You are controlling how much it is traveling and all. Na? Okay. So this is independent variable. This is dependent variable. Okay. Something like that we call. Okay. Displacement is dependent on time. Something. So now, whatever the dependent variable is there, like here in all the four cases, it is y. Na? If you reverse it, x also you can write. If you write dx by dy, like x is like dependent variable. Okay. Now linear means degree one. So degree one is for what? It is for dependent variable. Okay. So now what is the dependent variable here? For example, y. What is the degree of y here? 2. So this is not linear differential equation. Here dependent variable is y. What is the degree of y? 1. Yes, this is linear differential equation. What is the degree of y here? 1. But here second is also there. This is not linear differential equation. Here y is the dependent variable. What is the degree? 2. So this is not linear differential equation. Okay. So whenever you see linear differential equation, one thing, if you in linear differential equation, we have two types. In one LDE, we will write dy by dx type. Other one is dx by dy type. So if you're writing dy by dx, then y power must be 1. If you're writing like dx by dy, x power must be 1 there. Okay, in that. Let us see. If you see here, obviously x power is 2 here, 1 by is there. Okay, so but when you see y, its power is 1 only. No? So this is LDE in y. Okay, so important thing is identifying LDE. So after that, writing it in standard form. So what is standard form is any LDE. If it is in LDE form, if it is an LDE, the standard form will look something like this: P of x into y is equals to some q of x. You know how to solve from here. No? So your y into integrating factor, the solution will be this. Solution for this differential equation will be y into, okay, let me not call it as integrating factor, y into some function g of x is equals to q of x into g of x dx integral. So this will be the answer for differential equation. Now, what is that g of x? G of x is e power integral p of x dx. I hope you know already. Okay. Now, let us see for this one. Okay. Let us take one simple example and then not this much also. Let us take like this, something like this, or even simpler one. Okay, let us proceed by this one. So dy by dx plus 2x by x square minus 1 into y is equals to 1 by x square minus 1 whole square is there. Now what is p of x? This one. So first you find g of x, that is integrating factor. What is g of x? It is e power integral 2x by x square minus 1 dx, which is e power, what is that integral? Ln of x square minus 1, because f dash by f form. So it will be x square minus 1. Okay. So what is g of x integrating factor? X square minus 1. So what will be the answer of this differential equation? Y into integrating factor. What is the integrating factor? X square minus 1. And already what is there on the right hand side? X square minus 1 whole square. That into integrating factor. X square minus 1 dx integration. That's all. So y into x square minus 1 is equals to integral dx by x square minus 1. This is the answer. Of this integration you can do. No? It is ln of, sorry, 1 by 2 ln not direct integration only. No? Okay. Now, let us see one more question on this one. Let us take this. Now, is this LDE or not? First, you have to identify that one. Immediately, if I see this one, y is inside ln. Obviously, it can't be LDE in y. Obviously, it can't be. If it is LDE in y, dy by dx you have to have. Yeah, we have dy by dx, but the remaining y term should be linear. But if you see x terms, Only x is there, nothing else. So it can be LD in y. Yes, LD in x, sorry. How? If you want LD in x, what you have to do? Dx by dy you have to write. Now let us write here y into ln y into dx by dy plus x minus ln y equal to 0. Now dx by dy plus 1 by y into ln y into x minus 1 by y equal to 0. So it looks exactly like the previous form only, no? 1 by y into ln y into x equals to 1 by y. Okay. Previously what we had in this form, dy by dx whenever is there, here y will be there. And remaining these two functions will be in terms of x. Now if you write dx by dy, it should be ulta, reverse. These two are dx by dy, here x will be there. And remaining two, whichever are there, they should be functions of y. Yeah, they are like that. Now the integrating factor will be g of y. Okay, it will be in terms of y, no? E power integral p of x dy. That is, what is p of x? 1 by y. I am writing directly like this, dy. 1 by y ln y is this only, no? F dash by f. So it is e power ln of ln y. So which is ln y. Ln y is the integrating factor. So what will be the answer? Everything, whatever you have done here, if you interchange x and y, you will get the new LD in x answers. Okay. So x into g of y. What is g of y? ln y is equals to, right hand side you multiply that integrating factor. What is the integrating factor? ln y dy integrate. That's all. This will be the answer. Okay. Let us see the next one again. Is it LD in X or LD in Y? First, you need to identify that one. Okay. If you see Y terms, obviously Y square is there. Directly, you will say, oh, it is not LD in what here? Y. But if you see X also, X square is there. It is not LD in X also. Then what is this? This is neither LD in X nor LD in Y. This is directly homogeneous. Dy by dx is equals to minus of x square minus y square by 2xy. This is homogeneous or not? Every term second degree. Y equals to Vx, you can write over. Okay. So even though we are thinking LDE, but don't forget the previously learned ones. Okay. So you have to always come in order. Okay. Let us take some more. That means always you have to think from the previous ones. That is variables, separables or not. Yes or no, you have to think. Next, you have to think whether it is homogeneous or not. Yes or no. Next, the dy by dx equals to linear by linear, we have seen, line by line. Is it that one or not? Yes or no, you have to think like that. Next, you come to LDE. After this, there is one more level, that is Bernoullis. We'll come to that. Okay. Now, if I give you this one, now what do you see here? Simple. Line by line is there. Yes or not? We have seen that already, how to do line by line. But I can also see a LDE here. Why? Dy by dx is equals to 1 plus 1 by x into y. No? This is LDE only. No? Dy by dx plus minus 1 by x into y equals to 1. You can get the integrating factor. You can find it. Okay. Now let's take another one. Let's say this. Let's see this. It is LDE in x or y or like that. We have to decide. Now here, clearly y square and all is there, but x, what is there? Only x is there. No? So try writing it like LD in x, that is 1 plus y square into dx by dy plus x. What will be that? E power tan inverse y. No? Okay, that's it. Now you divide by 1 plus y square, you'll get dx by dy plus 1 by 1 plus y square into x is equals to e power tan inverse y by 1 plus y square. Correct? Now again, LDE done. You know what is the integrating factor? You know how to do it after this. Okay. Now let us take this one. Okay. If I take this example. Now, is this LDE first thing? You may say, sir, X is there. I can see only 1 degree is there in for X. Okay. So it can be LDE in X, you may say. But if you're writing LDE in X, then your dx by dy, whatever you are writing, its coefficient must be of 1 degree, like only one. Okay, let us write it like that. Okay, so y power 5 into x plus y into dx by dy. If you are thinking it is LD in x, okay. But if you divide by this, then your x coefficient can't be purely in terms of y, no? Yes or not? So it is not a LD in x. No, it is not a LD in y also. Then what? This kind of equations are nothing but Bernoullis equations. Okay, you see, Bernoullis equation will be simply, what is that here? What is the Bernoullis equation? It will be like LDE only, but on the right side, y power n will be there extra. Okay, so if I see here, where is that? Yeah, if I see here, it is x into dy by dx minus y is equals to y power 5 into x. If I divide by x, dy by dx plus minus 1 by x into y is equals to y power 5. So this is your Bernoullis equation. That means everything is like before only. That is dy by dx plus p of x into y is equals to some q of x. But extra here y power n will be there. Okay. So what you do in Bernoullis equation is simply divide by y power 5 everywhere. Okay, whatever is there, that y power n on the right hand side. Then you will get y power minus 5 into dy by dx plus minus 1 by x into y power minus 4 equals to 1. Now simply take whatever is there this as v. Y power minus 4, you take it as v. Then minus 4 times y power minus 5 dy will be dv. So replace this. This you write it as minus 1 by 4 times dv by dx plus minus 1 by x times v is equals to 1. Now this became LDE. Na? Just multiply with minus 4 dv by dx plus 4 by x into v is equals to minus 4. Now this is LDE. Now you can solve it. You'll get the answer. Now again, if you see this question, just mainly you see whether it is LDE in x or LDE in y. It is interesting. This is Bernoullis in x. Why I'll tell you. Okay. See, if you write dy by dx, then its coefficient should have, like, you should, the x and y should be, you should be able to separate, but that is not happening because we have seen here, na, the coefficient of whatever the derivative is there to write in LDE, you should be able to separate them. Like if I divide, then it should be pure. So this coefficient should be purely in terms of x or in terms of y. Then only we can do something. Okay. But here also, if you write dy, this is not purely in terms of x or y. Na? So dx by dy by dx, you forget directly. So what about dx by dy? If you write dx by dy, yes, purely in terms of y it is there. Okay. Then you can do something plus x square y equal to 0. That is what you get. Now divide by y. First thing first, dx by dy plus 1 by y into x plus x square equal to 0. Now this is dx by dy plus 1 by y into x is equals to minus x square. Now this is LDE in x only. No? Dx by dy is there. X is there. Now the coefficient is in terms of y. That's all. But on the right hand side, x square is there. Actually, LDE in x means it should be like dx by dy plus some p of y into x equals to q of y. But here again, x power n is coming, na? Just like Bernoullis in y. Okay, what you have to do? Divide by that x square. If you divide by that x square, what do you get? X power minus 2 into dx by dy plus 1 by y into, this will be x power minus 1 equals to minus 1. Now what you do? This thing you take it as v. So x power minus 1, you take it as v. You'll get minus of x power minus 2 dx as dv. So this is with dv by dy plus, what is that x power minus 1? V into 1 by y is equals to minus 1. Or let me write it as 1 by y into v, standard form, just like it looks. Okay. Now, is this LDE in V or not? You can solve, no? Okay. Like that only. One more question is there. You can take a screenshot. Yeah. So like this, mainly important part in mains is this identifying LDE. Okay. So what we have learned, I'll quickly say. LDE, what is LDE? We have seen. If it is in dy by dx, the important parts are, if dy by dx is there, its coefficient must be purely in terms of either x or y. Okay. Mixed terms should not be there. And the y power must be 1 in LDE. In Bernoullis, yeah, that extra y power n will come. Okay. That's all. Okay. If mainly, I think like more or less like if you are following from last, able to follow from last 15 minutes, if I am clear myself, I think you should get an idea how to decide whether it is dx by dy, LDE, like this. In dx by dy also you have another variant into x power n, same like Bernoullis in y. This is Bernoullis in y. Na? Bernoullis in x means x and y will get interchanged. Okay, that way. So these four varieties are only mainly thing which you have to stress in your practice. Okay. Yeah. So okay, guys. So we'll stop the lecture here. Yeah. Okay. Chalo. Okay, guys. So thank you, everyone. Yeah, I'm sharing the PDF, guys. Yeah. Okay. We'll continue again next class. Bye.